Hi everyone, this is your math guru. In this video, I'm going to show you how to find the area between the two curves shown in the diagram. The diagram shows the curve y equals 6x to the power of 3 over 2 and the part of the curve y equals 8 over x squared minus 2, which intersect at the point 1, 6. That's the coordinate of the point of intersection. Use integration to find the area of the shaded region enclosed by the two curves and the y-axis. I'm going to start by labeling my graph. We have the first curve, which has an exponential increase. We have that as y equals 6x 3 over 2. And the second curve, we have that as y equals 8 over x squared minus 2. To find the area between the two curves, we've been told that the both meet at point 1, 6. So point of intersection is 1 and 6. I'm going to split up the area between the two curves as shown. I have that as such that I have the point in which the first curve is touching the x-axis. We have that as point 0. And then because the coordinate of intersection is 1 and 6, we have the point on the x-axis as shown to be 1. So we have the areas between 0 and 1, and then 1 and the next point, which I'm going to show you how to calculate the point of intersection on the x-axis for the second graph. To find that point, I have y equals 8 over x squared minus 2. So we have that's x-intercept. The value of y is 0. So therefore, I have 0 equals 8 over x squared minus 2. To solve for x, I'm going to start by multiplying or moving my negative 2 to the right hand side. So I have 8 over x squared equals positive 2. What I've done is to add 2 to both sides. Then I have that's over 1. If I cross multiply, I have 8 times 1 and then 2 times x squared. So I have 2x squared equals to 8. Dividing both sides by 2, I have x squared equals to 4. And to find the value of x, I find the square root of both sides. So my x is equal to plus or minus 2. But if you look at the graph, the point of intersection falls on the positive x-axis. So therefore, the value of x equals to positive 2. So the point of intersection at that point will be x is 2 and y is 0. Now we can go ahead to find the area between the two curves. The first shaded region I'm going to find is the one enclosed by the shaded part. I have that as y equals 6x to the power of 3 over 2. Note that this is between the boundary of 0 and 1. So to find the area, I have the integral from 0 to 1 of 6x to the power of 3 over 2 with respect to x, because I have my boundaries. If I integrate, I have 6x to the power of 3 over 2 plus 1 divided by my new power. That's 3 over 2 plus 1 from 0 to 1. That's my upper and lower boundary. I'm going to tidy out what I have in the bracket first. So I have that as 6 divided by 3 over 2 plus 1, I have that is 12 over 5 times x to the power of 3 over 2 plus 1, that's 5 over 2 from 0 to 1, and that's equal to, starting from 1, I have 12 over 5 times 1 to the power of 5 over 2 is 1, so I have 12 over 5 minus, putting 0 or substituting 0 as x, that will give me x, or that will give me 0, because 0 times any number is still 0. So my final answer for the area of the first part of the shaded region will be 12 over 5. To find the second part, I have that between 1 and 2 as shown. That's the value of my upper and lower boundary. So therefore, I have the integral from 1 to 2 of, I have 8 over x squared. I'm going to put that in a bracket. So I have 8 over x squared minus 2 with respect to x. Then I have that as the integral from 1 to 2. I'm going to tidy up what I have in the bracket, make it linear. That's minus 2, applying laws of exponent. If I bring up my x, minus 2, and I have with respect to x. So if I integrate what I have in the bracket, that will be minus 8 x to the power of negative 1. Then I have minus 2x plus bracket from 1 to 2. That's equal to, I'll start with the 2 minus 8 and bracket 2 to the power of negative 1. I'm going to correct that because only 2 is raised to negative 1, which is my x, close bracket, minus 2 in bracket 2, and I close my bracket, minus, then I have 1, so that will be minus 8 minus 2, close bracket. If I simplify further, I have that as minus 4 minus 4 minus 10. And if I simplify that, I have that as positive 2. So therefore, to find the area on that, or between the two curves, I'm going to add the two values together. So I have therefore my area equals, I'm going to add my 12 over 5 plus my 2 to cater for the two regions. So I have 2 or 12 over 5 plus 2, which is equal to 22 over 5 square units. Thanks for watching. Bye.